Hello, and welcome to today's webinar, Innovating the Negative Pressure Wound Therapy Standard of Care. This webinar is part of the Wound Source Wound Care Product Navigator Series. The Wound Care Product Navigator Series is an easy-to-access interactive learning lab for healthcare professionals to get the latest information they need on the wound care products available to them. Each webinar segment will take a deep dive into a specific product technology. This program will review a recent study comparing two negative pressure wound therapy systems. Our sponsor for this installment is Medela. My name is Amy McCauley from Wound Source, and before we get started with today's webinar, I just want to go over a few details. As a reminder, Kestrel Health information does not give medical or reimbursement advice, nor do we provide medical or diagnostic services. The content of today's webinar is for informational purposes only. The views and opinions expressed in this webinar and content are solely those of the presenters and do not represent the views of Wound Source, Kestrel Health information, its affiliates, or subsidiary companies. Now I want to take a moment and provide you with an overview of your webinar console. At the bottom of your console are application tools that you can use during the webinar. To submit a question to our guest speaker, please select the Q&A app icon on your screen and type your question in the field provided and select Submit. We will try to get to all of your questions during the question and answer period. You can expand your slide area by clicking on the Maximize icon on the top right of the slide area or by dragging the bottom right corner of your slide area. Our sponsor has included additional information on today's products. On the left of your console, you will find the list of resources available for download. This webinar is being recorded and will be made available on demand. If you have any other requests or questions pertaining to this program, please contact our sponsor using the Contact Us app located in the tray of your console. At this point, I want to welcome our featured speaker, Kevin Ackerman. Kevin is the Vice President of Healthcare at Medela and has over 15 years of healthcare, medical sales, and marketing experience. Kevin, thank you so much for joining us today.
Hello, and thank you for joining today as we discuss innovating the NPWT standard of care. Our objectives for today will be to review the mode of action of negative pressure wound therapy, to discuss the fundamental requirements of NPWT systems to deliver the clinical benefits, and to compare the ability of System A, the Invia Liberty NPWT system from Medela, and System B, the VAC Ulta therapy system from 3M KCI, and their abilities to deliver the set levels of NPWT and manage fluid volumes. Negative pressure wound therapy is an important clinical therapy which has been used and researched for over 20 years. Throughout that time, the mechanisms of action supporting negative pressure wound therapy have been broadly researched and defined as the following 6 points. The ability to promote wound bed perfusion, the creation of macro deformation to draw the wound edges together, the delivery of micro deformation to promote granulation tissue formation, the removal of exudate and edema, the removal of potentially infectious materials, and the ability to maintain a moist wound environment. However, the design of a negative pressure wound therapy system must follow 3 main fundamentals in order to deliver upon these mechanisms of action. The first fundamental requirement for effective negative pressure wound therapy, which must be delivered by a system, is that the set level of negative pressure must be accurately and consistently delivered to the wound bed. By accurately and consistently delivering the set level of negative pressure to the wound bed, you can ensure that you deliver upon the first 3 mechanisms of action. In the promotion of wound bed perfusion, it's important to ensure that you've accurately delivered the negative pressure so that you get the right amount of hypoperfusion in the immediate surrounding wound tissue, which then will deliver an improvement in vascular endothelial growth factors, improvement in angiogenesis, as well as local vasodilation, capillary permeability, and collagen deposition. The set level of negative pressure also must be appropriately delivered to the wound bed in order to deliver upon the right amount of macro deformation, and additionally for micro deformation. If the set level of negative pressure delivered to the wound is not accurately delivered, you may affect the amount of cellular disruption that you receive at the wound bed and thereby actually increase or decrease the granulation tissue formation as desired. The second fundamental requirement for effective negative pressure wound therapy, fundamental B, is that a pressure gradient between the wound bed and the canister for efficient fluid removal must be created. As we will see through this presentation, the pressure gradient is critical in the ability to remove fluid. With the pressure gradient, you're able to then remove the excess exudate and edema and the potentially infectious materials. If a negative pressure wound therapy system is ineffective or incapable of delivering the pressure gradient, you will be unable to deliver mechanisms of action 4 or 5 in the ability to remove exudate and edema or the potentially infectious materials. And finally, the third fundamental requirement for negative pressure wound therapy system is fundamental C, and that a sealed wound environment must be maintained. Only systems which are able to deliver on all 3 fundamental requirements for NPWT are able to deliver upon all 6 of the mechanisms of action. For fundamental A, the set level of negative pressure must be accurately delivered to the wound bed, which delivers the first 3 mechanisms of action: the promotion of wound bed perfusion, macro deformation through drawing the wound edges together, and micro deformation for promotion of granulation tissue formation. We wanted to set up a test experiment to see how System A and System B compared. However, before we get into that test experiment, it's important to understand that some battery-powered NPWT units use an electronically controlled feedback system that ensures the maintenance of the selected pressure level, even in the presence of small air leaks, thereby guaranteeing the effectiveness of NPWT. And that the electronically controlled feedback system, not implemented in all mechanical systems, ensures the maintenance of the selected pressure level, giving the patient higher safety. And these are direct quotes from a recent European Wound Management Association review on NPWT. From the engineering perspective, this becomes incredibly critical in the delivery of the set negative pressure at the wound bed. On the slide, we actually have 3 images in which the wound and the device could be at different heights. You see on the furthest left image where the wound and the device are at the same height, the middle image where the wound is above the device, and the third image where the wound is below the device. In these 3 different scenarios, the ability to deliver negative pressure wound therapy can greatly vary. Without an electronically controlled feedback system, it is possible that the negative pressure given and delivered to the wound site can vary by upwards of 20% in each of the scenarios in the middle and on the right if you do not have the electronically controlled feedback system. Therefore, we created our Test 1 to test Fundamental A. In Test 1, we compared System A, the Medela India Liberty, and System B, the KCI 3M VAC Ultra, at 3 different heights with respect to the wound model and device to test whether the systems are able to effectively and consistently deliver the set level of negative pressure to the wound. We conducted both of these tests at 2 different pressure settings and recorded them 3 times each for each of the different heights to ensure that we're testing the different scenarios. You can see on the right a diagram of the test method for the accurate delivery of pressure to the wound bed. In essence, testing the same requirements that the European Wound Management Association set out for an electronically controlled feedback system. In this test model, we have pressure sensors designed in the mock wound bed, and we were consistently infusing a small amount of mock wound exudate throughout a 60-minute test duration. And again, we tested it at 2 different pressure settings of minus 125 millimeters of mercury and minus 75 millimeters of mercury, and 3 different heights, one with the pump and the wound at the same height, one with the pump 36 inches above the wound, and one with the pump 36 inches below the wound. After we ran these tests for the full 60 minutes, we have the results that we have seen. Through the use of an electronically controlled feedback system, both System A and System B meet the standard of care consistent with the UMA consensus review on negative pressure wound therapy devices. We can see through all 3 tests at the 3 different heights at both pressure settings that both System A and System B were able to meet the standard of care and effectively and reliably deliver the set level of negative pressure to the wound, whether it was minus 125 millimeters of mercury or minus 75 millimeters of mercury. This was done through the Medela system's double lumen tubing. The Medela system has the control lumen, which helps to ensure that the prescribed pressure is delivered at the wound site. This delivers a therapy that we call intelligent pressure control. Intelligent pressure control ensures that the prescribed pressure is delivered at the wound site regardless of any height differential between the wound and the pump. This ensures that Medela meets the NPWT standard of care. For the second fundamental, a pressure gradient between the wound bed and the canister for efficient fluid removal must be created. We know that this directly affects the ability to deliver on mechanisms of action 4 and 5, the removal of exudate and edema, and the removal of potentially infectious material. We also wanted to create a test setup to test whether or not System A and System B can effectively deliver on Fundamental B. Before we review the test setup for Fundamental B, it's important to understand how negative pressure wound therapy systems ensure that a pressure gradient is present to improve the removal of fluid or wound exudates. The electronically controlled feedback systems, which ensure that the set level of negative pressure is being delivered at the wound site, also introduce a pressure differential every time they open the check valve, referred to as airflow cycles or purges. These airflow cycles or purges check for blockages and actually create the necessary pressure gradient for the removal of fluid or exudates. In my experience, there are two different types of airflow cycles or purges. There are static purges, which check at preset intervals, in many cases once every 5 minutes. And there are dynamic airflow cycles, which sense changes in fluid volume or viscosity to prevent stagnation or tubing blockages. The reason why this is critical is that it's through the delivery of a pressure differential they are actually able to remove the fluid and effectively manage large fluid volumes. Through physics, the material and matter will always move from an area of high pressure to low pressure, as you can see in the model here. The area on the left with the blue dots is the high pressure. The area on the right with the orange dots is low pressure. And once these two areas are connected, you will always see the matter move from high pressure to low pressure in a relative setting. And it's important to understand that even the FDA defines this as a suction apparatus is engaged to create a vacuum within the wound bed that drives the wound exudate to be pumped from the wound bed into a collection canister. And the device is designed to provide a preset level of negative pressure to the wound bed. That pressure differential between the wound bed and the device will always create a high pressure to low pressure gradient, which helps to remove the fluid from the wound. To test Fundamental B, we created test method number 2, once again to compare the ability of System A and System B in their ability to efficiently remove fluid at a pressure setting of 125 millimeters of mercury. As we did in test method 1, we recorded the data 3 times per system. In this test method, we once again have a mock wound exudate with a pressure sensor in the mock wound. We delivered the negative pressure for up to 10 minutes, and then we introduced a bolus amount of the mock wound exudate, a bolus amount of 150 milliliters of the simulated wound fluid. We allowed this experiment to run for 125 minutes, just over 2 hours. And throughout the experiment, we measured the pressure being delivered at the wound site and the amount of exudate which actually was removed from the wound and delivered into the canister on the device. The results of this test are shown in the graph on the right. System A was able to evacuate 89% of the fluid in less than 20 minutes after fluid introduction. However, System B made minimal progress towards removing any of the fluid at all during the same amount of time. And in fact, System B never reached 89% fluid through removal throughout the duration of the experiment of 125 minutes. This shows that the Medela NPWT system exceeds the NPWT standard of care. And how does it do this? It does this once again with the double lumen tubing. With the double lumen tubing, there's a removal lumen which ensures that you have a pressure gradient to transport fluid from the wound to the canister. This delivers a technology that we call dynamic exudate removal. It's important in the ability to remove fluid effectively and efficiently, and we see this in the results of the fundamental B test. Not only in the ability to remove the fluid shown on this chart, but also in the ability to reestablish the set pressure at the wound site. Due to System A's ability to remove exudate more quickly to reestablish a patent system, it was also able to return the wound to the prescribed pressure more quickly. System B was unable to effectively remove the stimulated wound exudate quickly, and that directly impacted its ability to maintain the set pressure at the wound site. By having a patent system, a clear and unobstructed tubing between the wound site and the device, you can ensure that you're continuously delivering the set level of pressure. System A was able once again to remove 89% of the wound fluid in the first 20 minutes. And by removing that wound fluid so quickly, the set pressure was returned to the wound site within that 20 minutes. For System B, because it was unable to remove the wound fluid so quickly, it was challenged to reestablish the set level of negative pressure at the wound site. In some cases, actually experiencing excursions of the set level of negative pressure being delivered at the wound site beyond the spec range as defined on the chart you see on the right, the spec range of plus or minus 10 millimeters of mercury from the set level of negative pressure of minus 125 millimeters of mercury. Thereby, once again, the Medela India Liberty NPWT system exceeds the NPWT standard of care with its use of dynamic exudate removal. The final fundamental, Fundamental C, a sealed wound environment must be maintained. This is critical to ensure that you create a moist wound environment. Without a sealed environment, and through the presence of a small constant air leak, you may affect two key principles of negative pressure wound therapy. You may compromise the ability to maintain moist wound healing, and you may lose the ability to accurately and consistently deliver the prescribed pressure at the wound. If you introduce an air leak, a constant air leak, into an NPWT system, you end up compromising Fundamental A and the ability to deliver and maintain the set pressure at the wound. If the set level of negative pressure is not delivered to the wound bed, or if fluid is not efficiently removed from the tubing, then the full benefit of NPWT's unique mechanisms of action may not be realized. More so, systems that dynamically manage the changes in wound conditions can ensure that the tubing remains patent and more consistently accurately deliver the prescribed pressure to the wound bed. Innovation comes from improving upon the fundamentals of NPWT to deliver the therapy more efficiently. The Medela India NPWT system provides intelligent pressure control with dynamic exudate removal to help ensure NPWT is reliably delivered and controlled at the wound site, while helping prevent blockages with airflow cycles dynamically adapting multiple times per minute. This helps to deliver the NPWT fundamental requirements of accurate delivery to the pressure to the wound bed, efficient fluid removal, and maintaining a sealed wound environment to deliver on the 6 NPWT mechanisms of action. Because of this, the Medela India Liberty exceeds the NPWT standard of care. With that, we ask, healthcare is changing. How has your NPWT evolved? Thank you for joining today, and at this time, I'd be happy to take any questions you may have. I'll be also joined for the questions with one of our clinical sales specialists and a wound care specialist nurse, Peg Manacci. Thank you again.
Kevin, thank you so much for that presentation. We are now going to begin our Q&A session. Also joining us for this Q&A session is Peg Bonacci, who is this clinical sales specialist for Medela. If you have a question for Kevin or Peg related to today's program or Medela, please submit your question using the Q&A app found on your console. We'll try to get through as many questions as we can in the next few minutes. For our first question, is there any evidence to show faster wound healing with dynamic exudate removal?
Great. Thank you, Emmy, and always good to get questions coming right off the bat for these sessions. Obviously, I think Peg will have some input to this, but from my anecdotal experience and what we're seeing is obviously the ability to remove the fluid more quickly and thereby return the wound to the set pressure more quickly through a patent system. I think that the inference that we're making at this point in time is that you can get back to the mechanisms of action and deliver on those more quickly and more consistently. Anecdotally, I know I've seen personal experiences with patients who maybe have lymphedema or on skin grafts where it's absolutely critical, or you have challenges of excess fluid, where the dynamic exudate removal fluid and the ability to remove it more quickly has been beneficial. But maybe Peg, if you have some thoughts around that as well, it might be interesting to hear from a clinical perspective.
Yes, thank you. As practitioners, we know that chronic wound fluid is one of the major reasons why wounds stay chronic. So if we can efficiently and more quickly remove the chronic wound fluid from a wound, it just makes sense that we're going to heal that wound faster. That chronic wound fluid, when it's sitting in a wound, has inflammatory mediators in it like cytokines, MMPs. It also has infiltrating leukocytes that prevent the wound healing. Also, it's got a very high pH, and we know that wounds heal in a lower pH. So it just makes sense if you're dynamically removing that chronic wound fluid as needed, and the pump can sense that and remove it far more quickly, it just makes sense. You're going to be in a better healing environment for that wound.
Great. Thank
Kevin
you,
and Peg, for those answers. Next question. What does removing fluid more quickly have to do with returning to patency?
Yeah, a patent system, as we discussed in the presentation itself, is important. 15 years of experience on my side with negative pressure wound therapy from the product side and engineering side, I'm used to commonly seeing fluid dance in the tubing between the wound and the device and the canister itself. And the challenge that you get behind that is every time you have fluid in the tubing, you're actually delivering the pressure on the front side of that fluid in the tubing. And what's happening on the back side is an inference of the actual desired pressure. And so you don't have a one-to-one connection of the pressure at the pump that you're trying to deliver and that's been prescribed with what's being delivered at the wound if you have fluid in the tubing. There will always be some level of change that occurs because of the impact of the fluid in the tubing itself. But if you're able to get to a nice, clear, open, patent tubing, then at that point in time, you know that the pump, when you've set 125 millimeters of mercury or 80 millimeters of mercury, will actually be delivering that pressure itself down at the wound site. So having that pressure and having a patent system together are important to ensure that you can consistently deliver the set pressure at the wound site itself. Anytime you have fluid in the tubing, you're going to have some level of change, either plus or minus, to the desired set pressure at the wound by having fluid in the tubing, as we saw early on through the 3 different diagrams of the patient on the bed with the pump and wound at the same height, or the pump above or below the wound.
Great, thank you for that explanation. Before our next question, I'd like to invite our audience to take a moment to complete our quick poll, which should display on your screen here momentarily, to help us find out how many have joined us for today's session. The question is, how many people, in addition to yourself, are watching the webinar with you today? If you are attending this webinar by yourself, simply enter a 0. If you are in an in-service setting, an estimate is fine, and we thank you for your response. Now, while our audience is answering that question, here's another one for our presenters. What is your take on putting negative pressure wound therapy on circumferential defects on limbs, especially in the elderly population?
Yeah, that's a great question for Peg to answer. It's definitely a clinical one and outside my area of expertise. So Peg, what are your thoughts?
Well, we don't ever want to apply the dressing circumferentially on the lower limb. There's so much swelling and so much changes in the fluid situation that it could actually cause more pressure and start sort of like a tourniquet effect. So for that reason, we don't ever want to put the film and the adhesive circumferentially on a lower limb. Hope that makes sense.
Great, thank you. Here's our next question. I think, Kevin, this one's a good one for you. Why does a pressure gradient matter?
Yeah, it's the physics background of my engineering world makes me smile when I see these kind of questions, and I appreciate them. And at the end of the day, as we went into presentation, when you have a vacuum system, the material and the matter in the system will always move from an area of high relative pressure to an area of low relative pressure. And it's actually that relative difference between two sides of the system which creates the speed or the power with which you can remove or move any fluid. So having that gradient is critical in order to be able to effectively remove fluid or material from a wound to a canister. And the better that gradient, the more quickly that fluid will move. If you have the same pressure on both sides of, let's say, fluid in a tubing, the fluid itself will actually remain completely stagnant and won't go anywhere. So it's critical to actually having a pressure gradient to move fluid. And again, it always goes from relatively high to relatively low. And in this negative pressure wound therapy space, it's actually flipped, obviously, because minus 110 is actually higher than minus 125. But it's critical to make sure that fluid moves.
Kevin, I have something to add to that too. We talk about what chronic wound fluid does to the wound and to the healing process, but let's look at just from a nursing management and wound management issue. When you have fluid building up and you're only detecting it every 5 minutes, you are going to have more incidents of leakage. So, nurses have said, as we're presenting this and talking more about our dynamic exudate removal, they say, oh, well, your pump just takes better care of the wound and we see less alarms and less leakage. So when we look at it just from a practical standpoint, that pressure gradient is really important and helpful.
Absolutely. That's the end result of it. Totally. Thank you, Peg.
Mm-hmm.
Thank you both. Thank you both. For our next question, this audience member wants to know, would the fluctuations in pressure seen on the graph with the standard negative pressure wound therapy system used in the study impact healing? They seem like relatively small deviations.
Yeah, again, I think it's an interesting question. And, the fluctuations that we had seen, and then most specifically the final chart, I think might be what we're referring to here. There was a spec range that was called out on that chart. And that was a spec range that we actually took from prior poster sessions at wound conferences where it called out from the incumbent product or the largest device used in the market today, or the most commonly used device in the market today. And they called out their own specification range of plus or minus 10 millimeters of mercury. And so we really measured our product against what that previous poster and that other company had themselves called out as the desired specification range for the product on that poster. From the perspective of does it make a difference and do we know, I don't specifically know. I know that for years, we've always been challenged or asked at Medela before we had 125 millimeter setting on our devices, we were at minus 120, that difference was clinically concerning to many users. So while I don't know, I think that there might be clinicians, and Peg, it might be interesting for your perspective on it, but I do know for years that people were uncomfortable with a system that only delivered 120 millimeters of mercury. And so now we have one that delivers 125 and holds it and actually stays within the spec range that has been defined.
Yeah, the 125 was, what they did the first studies on, and that was the most efficient. So, we're there. Mm-hmm.
Great, thank you. Here's another one, and we've got time for just a few more questions. But I have seen data comparing the standard negative pressure wound therapy system used in the study to other devices, showing it removed nearly the same fluid amount as in your test over a 24-hour period and still maintained consistent pressure. How does that compare to the data you provided?
Yeah, I think it's interesting. The previous study, and that's actually the same study, I believe, that we're looking at then, where previous poster called out the specification range of plus or minus 10 millimeters of mercury. And in this case, they looked at 24 hours, and we've looked at 2 hours. And Peg can probably talk much more specifically about the importance of a 2-hour window in the negative pressure wound therapy space. But you know, the question I would have is a system that can do it over 2 hours versus a system that can do it over 24 hours. One is clearly outperforming the other, but Peg, that 2-hour window, it's critical, isn't it?
Well, yeah, you know, you have that chronic wound fluid sitting there. You have more dynamic cycles going through in that 2 hours. So, you know, it does make a difference.
And if I'm not mistaken, also, you know, with negative pressure wound therapy, if you lose vacuum for 2 hours, or if you have to shut a device off, you know, most systems, and I know ours, you actually have to remove the dressing then, because a 2-hour window without vacuum can lead to challenges because of the risks of maintaining that sealed environment, but with the fluid or the wound exudate perhaps pooling in the wound, it can create challenges in terms of negative effects on the wound. So 2 hours is a critical thing for negative pressure.
Yes, that's where we were going with that. Yes, I misunderstood the question. Yeah, we have a 2-hour window, and if that exudate stays in there longer, it's a medium for bacteria growth. Yep.
Great, thank you. Why is a pump that dynamically adjusts better than one that does not when it comes to patient care? Does it matter if your pump dynamically adjusts if it still purges the same as a standard negative pressure wound therapy system in low exuding wounds?
Yeah, I think, you know, the way that we looked at this from a development perspective at Medela was not all patients are the same and not all wounds are the same. And the fact that not all wounds are the same means they don't all have the same exudate levels, whether it's volume or viscosity. And so treating all the wounds the same could put some wounds at a disadvantage in their healing cascades. And so it was definitely within our interest to make a pump that could feel or respond, you know, to the changing wound conditions, whether it's wound to wound or throughout an individual wound's healing cascade. So I think dynamically responding and sensing, hey, is there a lot of fluid or is there thicker fluid versus less or no fluid, and how we manage the fluid removal and the pressure at the wound site, I think that can only be advantageous.
Yes, and again, going back to the nursing management, it's all about less alarms, and it's all about keeping that seal. And with our dynamic exudate removal, you're just checking that wound more frequently. So it's just inevitable that we have seen less alarms and less leaks. And that's really important, you know, factor in the day-to-day management of wounds with negative pressure.
Great, thank you. And we have time for just one more question. Can you explain again what you mean by a closed system versus an open system and why that matters? I don't understand why an open system can't measure pressure at the wound.
Yeah, so in there we briefly spoke early on in the presentation about open systems and closed systems, and the challenge you get is you want a closed system for a couple of reasons. A closed system helps to ensure that you maintain a moist wound healing environment. If you have an open system, it's like opening a window. You have a breeze continuously coming through. The second challenge, though, is by having an open system, you always have an air leak or a hole on the backside, which is continuously releasing the negative pressure that you're trying to create. And so as soon as you create that hole or that leak in the system, the negative pressure that you're setting at the pump versus delivering at the wound could and likely will vary. And that becomes even more complicated as soon as you put fluid into the system. If a wound exudates a small amount of fluid or a medium amount or a large amount, it goes from the wound into the tubing. At the point in time it gets in the tubing, you have to pay attention to gravity now and whether or not that fluid can be completely removed. In the case that the fluid just stagnates in the tubing, you can actually end up with a system where the pump thinks it's holding 125 millimeters of mercury, but it's simply pulling that on the fluid in the tubing. And actually at the wound, because you have an open system, not a completely closed system, you actually end up with less or no negative pressure at the wound itself. And so a closed system is critical in ensuring that you have a feedback loop in a multi-lumen system, but also that you maintain the pressure at the wound site consistently. And it really, if you're not maintaining that negative pressure, you end up running a risk that you're not delivering fully on the fundamentals or the mechanisms of action with negative pressure.
Great, thank you so much for that explanation. And before we end today's program, Kevin and Peg, do you have any final thoughts for our audience today?
Yes, thank you, Emmy. And from our perspective, we know that negative pressure has become a cornerstone of treatment of wounds. And there have been relatively few important developments over the past decade and a half, and the way that negative pressure is specifically delivered and controlled at the wound bed, and how you actually remove the fluid. It's our view that in the end, that the goal is to ensure that the negative pressure systems that we develop consistently deliver on the three fundamentals: the ability to maintain and control the pressure at the wound site, the ability to effectively remove the fluid, and to maintain a moist wound environment. And it's only by effectively delivering on these three fundamentals that you can maximize the negative pressure wound therapy mechanisms of action. We know that there's a lot of choice in the negative pressure market today, but not all systems equally deliver on these three fundamentals. So I thank everybody for joining and listening in today. And if you have additional questions that we weren't able to get through, I know the Medela team will be happy to respond and follow up with you. Thank you all.
Thank you. Bye-bye.
Thank you. And that's all the time we have for today's program. And thank you all for your questions. As Kevin mentioned, if your question was not answered today, a Medela representative will reach out to follow up. This webinar has been recorded and will be made available in full on demand after the program. Please look for our follow-up email that will alert you when the on-demand recording is available so that you can review any material you missed or simply go over the program again. Also, you will be redirected momentarily to a form to indicate your interest in speaking with a sales representative for Medela. I would like to extend a warm thank you to Medela for sponsoring today's program. On behalf of today's presenters, Kevin Ackerman and Peg Menacci, as well as the teams at Wound Source and Medela, thank you for joining us and for taking the time to view this webinar. Have a wonderful day.